Well, long time no tutorial. Hopefully this recording will go a bit smoother than the first few. Welcome back to Striking FPV R&D. My name's Ashton, and in a perfect world, I would have already printed my toroidal props and be flying them around the garden. But alas, here I am waiting for hardened steel nozzles to arrive so I can put an old roll of carbon PETG that I have laying around to good use. But for now, you all finally get a step-by-step on how to produce my toroidal propellers so that you can make your own. Now before I begin, I didn't get a chance to mention it in my last video because he uploaded after me, but a gentleman by the name of MoppelMat, or maybe just Matt Moppel, he printed my version 3 tri-loop toroidal designs in a 5-inch size using nylon carbon fiber. Very cool material. He buffed it out with a Dremel, made it really smooth, and it resulted in tri-loop blades that were actually lighter weight than injection molded tri-blades that he had laying around. And it performed comparably as well. So similar flight times, similar flight characteristics, a bit weird on punch outs apparently, but it worked well, and it was also perceivably quieter with the more whooshy noises. Now, I was quite excited by this result because not only was it my design and it actually performed well, but especially because it was an FDM print with a good, but not perfect finish. It's still a given that SLA is going to be the way to do this. But Matt's achievement kind of proves that FDM still has legs to go on. It's actually performing better than even I thought it would be. So it's making me quite hopeful for my eventual prints. So much like my past modeling tutorials, we're going to be using Fusion 360, which is free for non-commercial use. But a lot of the steps here I believe can be replicated in most of the other CAD programs like SolidWorks, FreeCAD, things like that. I will preface this though. There were a lot of decisions regarding my design that I mentioned in my last video, you can check that up there, that are based off making the print FDM friendly with minimal supports and or post-processing. And the biggest disclaimer is that I am not a professional engineer in any way, shape, or form, and there are some shortcuts to the way that I've done things which are not ideal for like real airfoil design, but for our purposes, I believe it to be close enough. With that, let's get started. So welcome back to Fusion 360, and this is the not-so-gem fan model that I used in my last video to demonstrate the idea behind varying angle of attack across the length of the blade. And the way I made this model was basically a bunch of offset planes, a bunch of offset blade profiles, and these blade profiles were basically mimicking the angle as demonstrated by these helixes or helices, whatever you want to call them. Now, the way these helixes or helices work is you basically generate a coil using the coil tool up here, set the ground plane, set the diameter to the diameter of the prop, and then crucially, the revolutions must be set to 1, and the height must be set to the pitch of the prop that you want to make. So in this case, 25.4 millimeters is 1 inch multiplied by 3 means that this is a 3-inch pitch helix. So if we click OK, we can then examine the other ones, and the midpoint, it's a smaller diameter, but the same height as well as the hub, the same smaller diameter again, but the same height, and from that you can determine roughly the angle that you need to work with. After that, you draw out the shape, which I'll demonstrate later, and then all you have to do is loft them together using the loft command. Basically, you have profile 1, 2, and 3. It will automatically sweep across and generate the profile. Then you run a circular pattern tool, which you can set to any number of blades actually. So I could set it to 6, 8. We could make a 10 blade fan like this by click OK. There you go. Starting to look like a turbine actually more than a propeller. And then you add the hub and everything's good. So that's the basic premise behind what designing a prop is like. The most crucial part being the varying angle of attack across the blades. Now, we can actually get into designing the toroidal prop. So we start out first with a new document, and just for fun, let's create our hub first so that we kind of have a reference of what's going on. Our hub is typically 12 millimeters in diameter with a 5 millimeter hole for the shaft. So we can just type in 5.2. I like to add 0.2 for a little bit extra clearance. And then after that, you finish the sketch, and then all you have to do is hit extrude and set it to 6 millimeters because that is also the standard height of our preferred prop hubs. Now, once you have that, I'm going to start recommending that we actually name the sketches, because normally sketch 1, 2, 3, 4, 5 is not very descriptive and will be much easier if we actually name them. So you just click the text, type in what you want. So this is hub 5mm. Same with the body, you can right click and rename as well, hub 5mm, and that is going to be our starting point. Now, we need to create the first element, which is the blade profile. Normally, we could just create it on this axis, but I'm not going to do that. I'm going to construct a plane, select the same axis, the plane axis, and then we're going to drag it up by about 3mm. This just means that we will clear the actual shaft area. Click OK, and then we select the plane and start our sketch. Now, crucially, we need to make sure 3D sketch is turned off, as well as show projected geometries, because we don't need to do the projected geometries thing just yet. And what we're going to do is we're going to draw our first shape. So to demonstrate how kind of chill we can do, let's just set off with a chord line of sorts. So this is at a 56-degree angle. That's fair enough. I'm going to click OK. It's now giving you warnings about the projected geometries, but like I said, we're not dealing with them, so we're not going to worry about that. In fact, once we've got the line in place, we can actually turn off the hub by clicking on the little eye next to it to hide it, and now we can work with this chord line. What is a chord line? The chord line is basically the furthest forward part of the blade, the leading edge of the blade, all the way to the trailing edge of the blade. That's not exactly how we're going to be using this, but it's pretty close enough for this point. Now we need to create the shape of the blade, and we're going to do that using the Fit Point Spline tool up over here. Click on the trailing edge, click on the leading edge, and then instead of clicking on the back again, just click anywhere down there. Now this tool is going to keep trying to draw for you. You just have to double click to stop it, and then press escape to exit the tool. Now we're going to zoom in to the top, and you see these green handles. These handles are basically going to help control the shape of our spline. So we can drag them back and forth, and that will basically define how wide of a curve that's going to generate. In this case, you'll notice I can't drag it up and down anymore because the sketch has automatically added a constraint, a horizontal or vertical one. That will show up as this little icon. We can get rid of that if you click on it and press delete, and then we can drag it freely around again. But actually, we are going to re-add that constraint a little bit later on. Or you know what? Control Z, Control Z, and that constraint is back, and now we can only move it left to right, which is fine, as we will see later. Down here, if we click on the line again, we get to see more handles for the spline. So what I'm going to do is I'm going to drag this one out just a little bit. Oh, gotta click again. Drag it over there. This I'm going to pull back, and we're also going to drag this handle a little bit to this point so that we have a bit of a cup shape to the blade, like in my actual V3 and V2 designs. At this point, we've kind of got the shape that we like, so we can delete the chord line. There's no need for that anymore. And then we're going to draw one last line along the base. And the reason why we're adding that and not making it perfectly pointy at the end is because, like I said before, we're trying to 3D print, and 3D prints work really well if you have a nice base that goes onto the build platform. So that is what this is going to be. At this point, we could just click Finish Sketch, but I wanted everything to be done parametrically, or at least more easy to edit and fine-tune for testing purposes, right? So what we're going to do is we're going to start adding dimensions. So we're going to click up here, the Sketch Dimension tool, and we're going to add little things. So start in the middle, click on the trailing edge, click on the bottom, and we'll just leave that at 2 millimeters. We're going to do the same for the top, 2 millimeters. And then I'm also going to do the same for the top again, but this time if you drag to the right, you then get to set the dimension vertically. Here it's saying that it's over-constrained because once again, there is actually, if we click on this point, a constraint in place. So I need to delete that first. Now I can re-add the sketch dimension. And there we go, 6 millimeters. I could then change this to 5 if I wanted to. Oh, no I can't because there's another constraint still left on these guys, of course. So I gotta delete that constraint. Now, one last try. Come on, baby. 5 mil. Now I can change the height relatively easily. So we'll deal with that a little bit later. The other thing I like to add a sketch dimension to is the base that we're working with. So that's 0.5. If you have a 0.4 millimeter nozzle on your print, it's usually a good idea to have one perimeter line, so it's 2 lines per blade. So I'm going to set this to 0.4 mil just to make sure that the bed adhesion is pretty decent. But if you were designing this for, say, an SLA print, then you could reduce that to like 0.2, 0.3, whatever you feel like. But this is just another way to control that. The other thing I'm going to add control things to is over here. I'm going to drag this up. Let's set that to 0.35, just make it a bit wider so it's nice and thick profile start. And then the last ones are going to be these handles, which would be quite fun. So let's do 1.35, make it a bit taller. Same for this one, 1.35. And then the horizontal 0.6 is fine. Same for this 0.4 then. And there we have it. We have our first profile. So let's finish the sketch. We're going to name this. We're going to call it Profile Start. So now we have our very first profile. And the hub is there just for scale. Let's turn it off again. The next step is to create the profile on the opposite side. So double click the profile we just created. Select the whole thing. Control C to copy, or you can right click and where is it? Copy. Finish the sketch, and now we're going to go to the side view, construct, select the same plane, but instead of going forward this way, we're going to go back the other way by -3 mils, swing across to this side, click on the plane, start a sketch, and paste. And what you get is an exact replica of the other one. I'm going to click OK, and then just for ease of use, we're going to hide the opposite one. Now what we need to do is flip it over. So how do we do that? Well, first of all, let's delete these weird lines. These lines are generated from the projected geometries because of the hub. So I'm going to delete those. No need for them. If I draw a line, it needs to be a vertical line. It can be literally anywhere. On top sometimes, but this is a better idea. Select the lines that we want to flip, and then we're going to use the mirror tool. If it's not there, you can click on Create and find Mirror. These 3 dots appear so that you can pin it to the toolbar. That's something that might be useful for you guys in the future, and something one of my commenters on the very first Fusion 360 tutorial I did suggested to me if I wanted to make things easier. So thanks to that dude. Anyway, we're going to click on the mirror tool, and it's already selected these objects. Now we just have to select the mirror line, which is the one that we just drew. Click, gives us a little preview on that side. Click OK, and there you have it. We have a mirrored shape. But of course, this one is still there. That's also totally fine. Just need to delete this and the mirror line because we don't need them. Make sure everything is gone. And then this, we can just quite simply use the move tool to drag it back into place. Now, obviously, this is now lacking in sketch dimensions, so we can start adding those back by clicking as such. This should be a relatively quick operation. I might fast forward this. And there we have it. That didn't take too much time at all, especially when you can fast forward things. And then we finish the sketch, and we can unhide the other one, and yeah, you can see with the hub as well, these are our start and end profiles for the blade. Let's just quickly rename the sketch to Profile End. Hide the hub again, because now we're going to create one more sketch that's roughly on the same plane. So click on Create Sketch. Click there. Let's zoom in relatively close to these things. Just draw a line on the ground. We'll make it 1 mil. For now, draw a spline that goes up by 2, down again. Remember, you need to double click to end the operation. Press Escape to exit the tool. And for this, I'm just gonna drag these control lines vertical. And this one, I'm gonna drag out just to make it a bit chubbier. Very bullet shaped. And now we get to add dimensions once more. So first of all, let's get this dimension set. The base doesn't need to be 1 millimeter thick at the edge, so we're just going to set it to 0.8. We could make it less, we could make it more. Same thing, we want this to remain center, so we're going to set this to 0.4, which is half of 0.8. And then we also want to control how much of the kind of outer bow we have, so let's just 0.18 this maybe. All good. And the final thing is to set it away from the center of our hub. So we click the outer edge, click down here, and then now, what is it? It's 25.4 is 1 inch, multiplied by 3 inches is our diameter. divided by 2 is our radius. Click OK, and it moves the whole thing over here. So that is done. Finish the sketch and rename this to Profile Edge. Now we're starting to get somewhere. Now if we were to use the loft tool and try to loft these together, click 1 and 2, you get some really odd behaviors. So yeah, it's trying to do something, it's not doing a great job. Cancel that, because now we need to add one more crucial part, and that is going to be the mid profiles. So to do that, we're going to construct a plane, but instead of clicking on the right, we're going to click on the front back plane, and we're going to drag it roughly halfway between the start hubs and the edge. And how's this work? It's got to be 25.4 multiplied by 3 divided by 2 to get the radius, and divided by 2 again to get the halfway point. Click OK, select it, start a sketch, and now we start drawing. So if I recall correctly, what we can do, let's just start at 5 mil instead of at 6. So we'll click there, drag it out, and it's got to be about a 26, 24. I think it's 26. Yeah, we'll do 26 as our preferred angle in this case. Once again, we're going to draw a line forward. That can be 0.8. And now we're going to draw our spline, trailing edge, leading edge, and then back to the end of the base. Double click. And now you can see it's much, much narrower than the other ones that we used to do. So we got to zoom in here and drag this out. Okay, that's looking not too bad. Maybe we need to add a bit of a bow, so let's just drag this up. Nice, okay. We'll drag this one up as well. And I think that's not too bad of a shape. I'm just going to make this a little bit wider. Okay, not too bad. Let's press enter and be happy with that. There's no need to press enter apparently. Delete the chord line, and now we need to dimension this. So dimensions, we've already got our 0.8 there, which is fine. We then also need to dimension from the leading edge to the rear edge, and that's set to 10. That's no problem. Need to set the height of that as well to be safe. That's 5. Then we can add dimensions to our handles, and we'll just leave them as they are, but we can of course modify them later to our liking. Last one. And now, of course, we need to set the distance away from the hub. So all we have to do is select the outer edge, select the center, and now we do our weird calculations. 25.4 multiplied by 3 divided by 2 divided by 2 again. All good. Now we need one on the opposite side as well. So let's press escape, select that, and we should be able to right-click copy. And if I Control V to paste, has it done it? I don't know. No, it hasn't done it yet. Control V is being weird. Let me try that again. Control C, Control V. Ah, there we go. Now we just have to drag this across, roughly where we need it. It doesn't have to be perfect. And what else? Now we need to set the dimension from the outer point, which is this, all the way back to the center. Same calculation goes 25.4 times 3 divided by 2 divided by 2. And there we have it. The only thing left to really set is basically these control points. So this is a bit of a weirder one. I will set the distance between these two like so, and then the distance between these two like so as well. So that can be 0.08, so 0.01 to make it a bit taller, and this can be 0.4. Excellent. And we'll do the same with this one. There to there. 0.1, and the same here, 0.4. So now once again we're in a position where we can better control the whole thing, except now this is lifted off the ground strangely, so I need to drag that down, and we're going to lock the horizontal vertical there. I think the same thing happened here. This moved. Yes, it did slide while I added those dimensions, so let's just drag it back down to where it needs to be. You know what, if we're not satisfied with just dragging it around, what we can also do is dimension this, the top one, with the center of our world. If we do that, we can set that to 5 exactly, and that will shift the whole thing down as well. So let's just drag it over here. And that should be it. Finish the sketch, and now let's look at our fine work. So at this point, we're actually able to try creating the loft. So let's click our loft tool over here. We're going to add our first profile, which is the start profile. Where is it? Here we go. The next profile, the next profile, the next profile, and the next one. If we click OK, you can now see that our operation has turned into a kind of funny diamond shape. It's not very circular. The reason for that is because we haven't added any rails yet. So we got to undo this and start working on our rails. And before we do that, I forgot to name the sketch. Let's set that to profile mid, the mid profile. So the first one is very easy. All we have to do is create on the ground plane. And this is where things become a little bit weird, because we could just freestyle this. Make sure show projected geometries is on. We could just click on the outer edge, outer edge, outer edge, outer edge of the bottom plane, and outer edge, and then finish. And this ends up producing a profile similar to what the lofting tool did. But the issue with running this operation is that if we try to shape this into the ideal shape, it doesn't quite work. It has some slightly odd behaviors that are a little bit difficult to work with. So, just to demonstrate, I'll try to clean it up, but ultimately it's not really producing the shape that we want. So let's undo this. And now what we're going to do is we're going to create a circle. And the circle, 2-point circle from the outer edge down to the center. The important thing about this circle is that we're not using it as a rail. We're just going to use it as a guide. So you click on it and press X, and that turns it into a dotted line, which allows us to basically not use it as a rail. So all the solid body operations will not reference it anymore. It's just there for us while we design. So what we need to do now is create a spline. Once again, we're going to start at our outer edge of the base over there, so you can see. So we click, and then click, and I'm going to end it there for reasons that I'll explain a little bit later, maybe. Double click, escape to exit the tool. Now what we want to do is set our handles to be horizontal. So easiest way to do this, this one has already locked itself to the circle, but the circle's moving around, so we don't need it to do that. What we can do though is we can add constraints using this. So horizontal, vertical, let's just select the entire line that is the handle, smash that, and that becomes completely horizontal. Same thing will go for this, and the same thing can be done for this handle line. And now they're all horizontal or vertical, which is crucial for what we're about to do. Now the thing is this, we kind of want this line to follow the circle as much as it can. So this top one is already, pretty close. We can drag it in a little bit to get it a little closer. The same for this. If we drag this up or down, I'm getting it more along the line, which is kind of what we want. And then this one is kind of the spanner in the works because it's off the line completely. But this is fine because it's not leading anywhere. It is coming out of the hub. So all we need to do is just make it look nice and rounded, and that will probably do us fine. Now we got to continue the whole thing, but the next one is a little bit weirder because it's not following the outer line. It needs to join here. So the way we can do that is we go to create and we make an ellipse. You got to click the center, click the outer, and then click the point to make our sort of egg shape. And we're going to click on basically here. Once again, select the line, press X to convert it to a construction line. And now we have our second guide to the whole thing. In fact, while we're here, we can trim this bit because we don't need it. And we can trim the outer bit because we don't need it. And we have our line shape, our guide shape. Now we click on the spline tool, zoom in on that upper edge, click on this point there, and then click on the final one at the bottom, double click to end the operation, escape to exit the tool. And once again, we're going to use our horizontal vertical thing to make these lines completely vertical or horizontal, either or. The reason why you want them to match, in this case, these two sets of handles for this line as well as for the exiting line, if they are both completely horizontal together, then it means when the lines meet, there's no noticeable angle difference or change or jaggedness. So if they're mismatched, then the line curve will be like this, and then the next one will come in like that, and it becomes a point. But if the control lines are with each other, then the curve will be much smoother. So by setting it there, we can then drag this, wrong one. Let's drag the correct one, the small one, to roughly follow that line down there. It can be a little bit narrower for reasons that are obvious later on when you think about toroidal shapes. Having it a little bit pointier is going to be a little bit better for the angle of attack. The rest of this is roughly okay, and then this one can just come in like that. And there you have it. We have our first set of rails. Now we just need to do the same thing for the inner side. So, same deal. Let's create a spline. Clickety, clickety, and clickety. Double click. Escape. We're going to set this to be horizontal. Set that to be horizontal. And set this to be horizontal. And here's the trick. To get roughly similar results is you want these lines to be about the same. You can loft them to each other. I'm not going to do that for reasons that might become obvious. We're going to make this roughly the same, and then we're going to make that roughly the same. And here's the thing, right? Even though they're matched, what ends up happening is the width of our base still becomes narrower between the control points in the middle section between the actual points. So my solution to this is have the start and end be roughly the same, but then we'll just make the middle section a little bit smaller. And as you can see, that kind of brings things back to balance. So I'm just gonna maybe plot that there. And I'm relatively happy with that for now. We'll continue our adventure by creating the rest of the spline for the rest of the bottom rail. That goes there. Double click once more, end it. Gonna drag this spline almost level and then use the tool to make it horizontal. Why is that not working? Let's double check what I'm clicking on. Alright, click that. There we go. Click this one to make it vertical and click that one to make it horizontal. All good. And once again, we're just gonna roughly match these with one another. Except for the mid one, which needs to be a bit smaller to help maintain the blade, the base thickness. And with that, I'm pretty satisfied. So I'm going to finish the sketch. Don't forget to name it. We're going to call this rail and call it base. So it's the base rail. Now this is already looking kind of interesting. So let's, for fun, do the loft command. So click on loft. We're going to select our first profile, our second profile, and then now, just to show you how it's going to work, we'll click on the plus sign for rails and select our bottom rails, 1 and 2. Now, as you can see, it's making the shape conform to the bottom rail, but it's still not guiding the top very good. In fact, if I go completely vertical, this shape I don't like. It doesn't make any sense, so we're going to have to fix that. But anyway, let's add more profiles to see how it continues. Ooh, there's an error there. And this error actually happens quite frequently. If I cancel that additional profile there and click OK, what happens when you finish an operation, it always hides the sketches that you just used if they're the first time being used. So I'm going to unhide them using the tools here. We're going to loft again, and we're going to try and continue the shape from there to here, no problem. And we'll add the rails on the bottom. And as you can see, it was actually fine creating that shape. So for some reason, if you try to complete the whole thing with rails, it's not happy. But if you do 1/2 first, or even 1/4 sometimes, it will be happier. So now I can add the final profile and click OK, and there you go. We now have a very, very strange looking toroidal prop loop. But like I said, this is not done because we need to add one more set of rails. So what we're going to do, we'll undo to this point, but we're going to add another sketch. And this is going to need the construct, select the ground plane, and lift it up to roughly the height of that, which is actually 6 millimeters. Click OK. select the elevated plane. You can see it's at the same level as the top of our start profiles, and we're going to click Sketch. And once again, before we actually begin drawing out the whole thing, we should draw our guide circle. So let's start with circle, 2-point circle, click on the center, and this time instead of clicking on the outer end, we're going to click on the midpoint of the edge profile. Select that circle, press X to turn it into a guideline, go to ellipse, select the center of our circle. Is that the center of our circle? Yes, it is. Select one of the outer edges, and then we're going to click on this rail point here. Once again, select that, press X to turn it into a guideline, a construction line, and then we're going to trim off the ones that we don't need. So we don't need that one, and we don't need that one, because we're trying to follow this top outer edge. So once we have that, now we can actually create our funny splines. So let's click on the first point, the second point, and then click on the midpoint. Double click to end it, press Escape to exit the tool. Let's drag our control roughly horizontal, and then just select the line, press the constraint, click on this one to constrain it as well as this one. Went the wrong way, so undo, drag it closer to horizontal, and then use the tool. Where is it? Hang on, select the line. There we go. And now we have our control points. Press Escape to stop using the tool. And once again, we're going to drag this in to kind of roughly follow the shape here. There we go. That's nice. That went really quickly. I'm very satisfied with that. Alright, and the final bit, we'll create the spline. Click on the top one there, click on the outer one here, and then click on the final one there. Double click. This should work fine if I use the tool there. Horizontal, vertical, horizontal. Press Escape to exit the tool. And now we just need to try and match the curvature of that outer thing. So that is about right. Oh, it went in. Why did it go in? Oh no! It accidentally snapped to one of the projected geometries, and it's added a constraint there. So I can either delete the constraint or I can undo. I'll just undo it, that makes sense. So let's just drag it in place. Hopefully it's not going to snap again. There we go. Hold that in as well. Oh, it's giving me a menu. Click again to get out of it. Drag that here. Nice. And then the last one, we should drag this a little bit further in, like so. And you know what? I think I'm pretty satisfied with that, because it also semi-mimics the bottom rail, so everything seems to be about right. So with that, we can click Finish Sketch, and it's all ready to go. Except you'll notice it's not, because our mid profile is actually only 5 millimeters tall, and our edge profile is only 2 millimeters tall, and the sketch is floating above them at 6 millimeters above the ground plane. So how do we deal with that? Well, first of all, let's rename our sketch to rail and what do we call it? Upper, I guess. We're going to go back in, and remember before I said turn off 3D Sketch? Well, now we get to turn it on. So with 3D Sketch on, we can rotate to the side, and we can start to mess with these control points in 3D space. So for these two, we'll click one, hold Shift, and then select the other. If I click on the Move and Copy tool, hopefully I should be able to drag this down. And I can't. The reason why I can't is because there is, once again, a constraint in place. So we need to go back to the vertical and have a look. And indeed, there's a constraint here that we need to delete. So select it, delete it, all good. Let's try this again. Select our 2 points that we want to shift down. Select the Move tool and drag down. There we go. So now we can drag it up and down in 3D space like so. All good fun. So we'll just drag it down to that point. Click OK. And now we need to drag this down. And of course, there's a bunch of constraints that have been applied to it. So select and press delete. Make sure that there are none floating around on the handles, because if the handles have constraints on them that are going to limit it, that will also cause issues. They don't. So let's click on our point, click on our Move tool, and once again, drag it down to where we need it to be. And as you can see, one of them decided not to go. So with that, I can select that and then also drag it down. It's not dragging down, therefore it means there's a constraint on it. So let's have a look, click it, and yep, constraints have reappeared. So remove those. Now we should be able to drag it down. I am dragging one of the ellipses down, so that's not what I wanted, is it? Let's click on the line itself, and then click on the point. Let's click on the handles, make sure we've got it. Let's just try this one more time. It's still dragging that line, so let's leave that. Come on. Oh, you're being very, very irritating. This is what we're trying to do, isn't it? Yes. What if I delete this? And then drag. Oh, it's still trying to drag the ellipse. Let's just delete those because we don't really need them anymore. Now we have only that left. There we go. How irritating. Well, if somebody knows how to better deal with that, let me know in the comments. That's just one of the things that happens when you're flying by the seat of your pants in Fusion 360. Anyway, click OK. Now the rails are roughly where they need to be. This one is too low for some reason, so let's lift that back up. How bizarre. How bizarre that that was different. Does that mean that this particular rail is at the wrong height? Let's check profile mid. Nope, it's exactly where it should be. There we go. It's always good to check that your sketches line up, because if the rails don't line up, the loft tool will not work. Anyway, I think we are now at a point where I can actually do the full loft. So let's click on our loft tool, select the first profile, the second profile, and at this point we can add the bottom rails. And now, the moment of truth, the top rail. Drum roll, please. Hey, okay, it didn't throw an error. Believe me, I've been doing this for a while and I'm so scared to click on all the rails because it very often throws an error because of a tiny misalignment or even weird errors like, oh, it's tangent to the profile, which I don't understand why that's an issue. But anyway, with that, click add. We'll add another profile. And knowing my luck, this is going to throw an error if I select this one. Yes, it has. So just click the X, remove that. We'll click OK for now. Once again, the sketches have disappeared, so we need to unhide them again. And then we'll continue with our loft command. Click there, add the rails again, 1, 2, 3, and then we'll add our final profile there. Click OK, and now we can actually hide the shapes, because this, ladies and gentlemen, is roughly what we were aiming for. Now, if you notice that maybe this could have a slightly more rounded shape on that side, so the way we can fix that is, it is the upper rail, so all I have to do is pull this out a little bit more and maybe lengthen that just a bit. Now this isn't moving because it's now in 3D space, so what happens when handles and points are in 3D space is then you need to refer to this move tool because it's no longer 2D, and then we can drag it a little bit to help develop the shape a little bit more. We can do the same for this handle over here. Click OK, finish sketch, and if all is good, yes, it's automatically adjusted the command, the lofting command, to produce the shape. Now the other thing you'll notice if we view this from the right is that there's a bit of a weird slopey thing going on, and that is once again because of the handle. So to fix that, we need to go back into our upper rail, double click that, and this time we view from the side, and you'll see that if we go completely right, these handles are completely horizontal, and that's why this shape is being made. So what we need to do is select one of the handles, click on the move tool, and that's not working once again because there is a constraint in place. So we just need to delete said constraint. Same for the other side. And once again, select the handle. No constraints this time. Should be able to drag up and down. Yes, we can. So we go back to the right profile. This time we drag it down like so, and we can start to develop a nicer kind of shape for the whole thing. Let's try 0.5. What I would like to do in a perfect world is not have this lift up any higher than the top. So 0.5 is good. What about 6? 6 is not bad. 7 is starting to go a little bit too high. You can see these green lines here are showing that it's going above the original plane. So, you know what, let's just be safe and set it to 0.5, maybe 5.5, that'll do. Click OK, and then we can do the same for the handles over here. Click on the move tool, drag it down. That is clearly way too much, so let's just try 0.55 again, or just 0.5. 0.5, it is. But you'll notice that it's not quite matching, and matching is probably more important at this point, so we can try 0.4. Oh no, 0.5, 5, 0.6, 6.6. Ooh, but it goes too high on that side. So, you know what? It's not going to match. Let's just go with 0.45. Click OK, finish the sketch, and once again, the thing did not blow up. Hooray! So this, I can safely say, is our final blade loop toroid thing. Now, if you don't periodically save your work, you are a fool. So let's just do that. Control S. I'll call this the tutorial toroidal design. It's in my Toroidal Propellers folder, so we'll click save. That's now going to save it to the cloud, and our work is basically backed up. Hooray. It's now added over here on the left side. You can see it's not perfect. If I really wanted to make this a bit more round, it looks like an O shape. I can, once again, double click on the rail base and make some small adjustments. So I can drag this control point. Maybe I want to drag that down a bit more. Same for this one slightly. This one can move out maybe a touch. Let's just go in like there. Same for this. And you know what? If I finish the sketch, that's made it a little bit better, but this is kind of the point where you can start to make your tweaks to your design as you wish. If I wanted this inner edge to be a bit more aggressive, so I could actually select these short ones and move them in and make them pointier, like so. Click finish, and you'll see it's made this inner side a bit pointier. So if I then go to the upper and do the same, we just drag the short one in a little bit more. I can't drag it in, which means there's probably a constraint on it. Oh no, because this is the upper rail, so I need to select this. So I'll drag that in by a bit, click OK, finish sketch. And you can see it's making it a little bit pointier there, which is actually better for the blade profile in terms of trying to become a shallower angle of attack closer to the edge. And in theory, we should also be able to even lower the edge a little bit more. So let's just try that. Let's double click on profile edge. And did I even set the height of this? I didn't, so I've got to do that. Let's select our top one there. Oh, that was set to 2.5. It was supposed to be set to 2, so let's set it to 2. Pull it down a bit. You know what, 1.5. Let's go for broke, see what happens. Finish the sketch. Now the loft, it's not recalculated because one thing is wrong. When we shifted that down, if we reveal the upper rail is still following the original design. It's not actually at the new height. So for that, we need to go into the upper rail again, view it from the side, select it, and drag it down to where it needs to be. Same for this one. Drag that down where it needs to be. Click OK. Finish the sketch. And there you have it. We've now made our first kind of post-generational operation to make the blade even thinner at the edge. That's actually really cool looking. And therefore even sharper in terms of the angle of attack at the edge. So that is pretty decent. But there you can see, let's Control S and save this. There you can see how we can then modify the design sort of iterationally. You know, we don't have to create it from scratch every time. We can go back into previous steps. Previous steps may break the process, like when I moved one of the edges and the top rail no longer aligned. But as long as you're aware of what needs to become aligned, then things should be okay. Now the other thing is this, there might be a way to get them to automatically align. I don't know yet, but if somebody wants to tell me in the comments, you're more than welcome to. Now the interesting thing happens where we get to actually start producing the shape. So that was almost sticking up. As a first step, we've already created our first blade, so we'll just call it loop 1. And this is where things are going to get messy. So let's hide the hub again. We're going to select our loop, And we're going to click on the circular pattern tool, select the vertical axis, and that's made 6. We're not going to do 6. Let's just make a try loop, because I like the try loop. So we type in 3, we click OK, and now we have basically 3 of them. But you'll notice that they're doing the thing where they're intersecting one another. And the other thing you'll notice, which I find quite interesting, is that the leading edge over here is actually leaning over that bit. And this is not good for the way that we want things to intersect. So what I'm going to do to make sure that this part is on top of that is we're going to go back into the upper rail, and we're going to adjust this curve here a little bit. So whereas I moved it down by 4, let's move it back up by 0.2. Click OK, finish the sketch, and as you can see, it is now getting cut completely in half by the trailing blade. And this is a good thing because now we get to perform the cutting operation. So the way this works is we click on our original loop here, and we're going to click on Combine, even though we're not actually going to combine it. This is a tool where things can be added to one another or subtracted from one another, which is very cool. So if we click on that, we can now select the target body, which is already here. We need to select a tool body, which is going to be this one. And then we need to select the operation. Currently it's set to join, but we can also set it to cut. But what that will do is this second object will be used to slice through the first one. All we have to do is click OK. Second object disappears, but now we have a very nice clean cut through our first one, such that this is now our first object. Loop 2 is just there along for the ride, and then loop 1 is now just this. So this is where we start to get folders built up, because I would like to just delete that, but if I do that, it deletes everything or gets rid of the whole option. So don't do that. Let's undo. What you need to do is what I did. I created a new folder and I called it offcuts because it's not necessary to use anymore. So loop, I'm just going to put that in there. And this one I also don't need, so I'm just going to stick it in there. And they are hidden, so they're no longer needed. We're going to take our main loop, let's call it main loop, and once again, circular pattern, vertical axis, 3 of them, and there you have something a lot more like what we're trying to build. At this point, we can once again use the combine command, but instead of cutting, we're going to join them. We select the other 2 bodies like so, click OK, and now this has become one piece. The reason why we want it one piece is because we're going to do one more operation. We're going to select this edge, and this edge, and we're going to attempt to smooth it by using the fillet command. So you click fillet, set the fillet size, I guess, to 1, and we click OK. And now you can see what it's done. It's made a nice, smooth kind of transition, which helps for strength, especially at the base, because now the base has this really nice shape. And at this point, we're basically almost done. Now all you need to do is add the hub back in and run the same operation again. Let's click Combine, select the blades, click OK, and behold, we have our first 3x3x3, what do we call it, counterclockwise. The only thing left to do to just make this a little bit nicer is maybe try smoothing this edge. So if we click on these, you'll see what happens or doesn't happen. If I click fillet and type in 1, an error occurs. And that's because this is way too close to the top. It can't actually create the fillet. So what we can do instead, you select the top surface and we offset it by, say, 2 millimeters, just to raise it up. From this point, now we can select those edges again, and we can try the operation again. So click fillet, type in 1, and it didn't work again. It genuinely hates me. What about a smaller amount? 0.4. 0.5 works. It's happy with 0.5. What about 6, 7, 8, 9, 1? So it doesn't like 1. 0.99. Haha. You know what? I think I know what this is caused by, actually. This is probably everything to do with the tightness of the leading edge here, such that if I made the leading edge a little bit fatter, I bet I could probably get it to work. So let's test that theory by going back to our profile start and making this 0.5. Okay. And we'll do profile end. Why? It's just renamed that one. Double click profile end. 0.5. Click OK. All right. Now let's try filleting these. There you go. I can now fillet them much nicer than before. It's all to do with all the different radiuses, radii that we've been setting for these different parts. So with that, we click OK. And now we can pull this back down by -2. And you'll see it's managed to chop off the end and make this nice little circly bit there. So we keep our fillet and we keep everything looking smooth. The only thing left to do is add a little bit of chamfer to our shaft area by 0.5. And then of course, if you wanted to be super proper, we can also mirror this right here. So if we call this 3x3x3 counterclockwise, we can press mirror, select the plane as that, make sure it's set to make a new body instead of join, click OK, and then we can rename this now just clockwise. We have both of our toroidal tri-loops. Now as a bonus feature, if you wanted to actually make a bi-blade instead of a tri-blade, then there is maybe 1 or 2 things that we could change slightly with this design. So what we'll do, I'll just undo everything that I did previously. Press delete on the history. We can hide our hub once again. Where's our hub? There it is. And what we can do, instead of doing a circular operation which produces 3, we can change this operation to just make 2. And that will do this. And then at this point, you should be able to simply combine literally everything together. Let's lift this up one more time. Combine. Oh, no. Let's lift that up by a little bit, by 2. Select everything, combine, click OK. And as you can see, there's no offcuts anymore. That has worked. But you can see that a strange thing has happened because of the blade profiles. And this is not really ideal for what we're trying to do, so I'm going to demonstrate how to solve that. Basically, I should be able to just go back to the start profile and shift it forward by, like, how do we do this? Let's set to 0. No, not 0. We can't do 0. That's not possible. Set that to 1. Set this to 3. Actually, let's set this to 0. Oh, it doesn't let you do that. Let's set it to 0.1 and set this to 4. Or 3.9, technically. Save. And that has improved things, but now we need to solve the trailing profile. So go to profile end, and we'll do the same thing here. We'll set this to 3.9. Oh no, and we'll set this to 0.1. Oh no, that's not working. So let's solve this. How do we solve this? I've got to set this dimension to be 3.9. There we go, and set this one to 0.1. Also should work. Nope, because I selected the wrong one. What am I doing? Okay, select this and the upper one there. Sorry. Set that to 0.1. So that's just shifted everything forward there. And now if we click OK, behold, it has improved things, but not 100%. And the reason for that is most likely to do with the upper rail, because indeed it doesn't match. So let's go to rail upper. Reveal the profile end. Oh no, that's in the right place. So what is the issue? Let's go back into here and see what it's all happy with. The rails do not intersect all profiles. Because that has slid out. So what we do, go to the upper rail, and we need to move this back to where it needs to be. Same with this one. Click OK. Finish the sketch. And there we have it. We now have the blades much further away from each other coming out of the hub, so we can hide our profiles again. Let's try doing the thing. Let's add a fillet to these. Oh, not there. Select the form, click fillet. 1. It's okay. and then we'll pull this down by 2 using the offset tool. Now we have a bi-loop based off the exact tri-loop design with some small modifications. And that, I think, is pretty much it. I'm not going to mirror this. So that was exhausting. This is like the 3rd attempt to get through this, but I think that worked out not too bad. But remember again, I'm not a professional. I'm not very good with Fusion 360. I scrape by, as you can see. But if you're a much more talented person, then you've probably found flaws with my methodology and maybe ways to improve upon it, or maybe you prefer to use surface modeling. That's up to you if you're at that level. If you're not at that level and you're actually looking to me for help, then I hope this has helped you, but I do urge you to look into more Fusion 360 tutorials that are more specific on various methods for doing things. There's a lot of propeller tutorials that use surface modeling, for example, so by all means, have a look at them and maybe develop your own methodology to doing all of this. But that is about it. So if you found this video useful, please like and share, maybe buy me a coffee if you feel like it. There's a link down in the description. If you have any questions or suggestions regarding the whole thing, then, leave a comment down below. And of course, please subscribe for more content like this. Maybe even check out some of my older tutorials, like the first one where I made some GoPro mount for your drone. You measure things yourself. And if you did use this video to help you create your own design, and you think your design could be a decent performer, then please share with the wider community as a whole. Let us know. Tag me if you feel like it. And of course, if you want to give a bit of credit to how you learned to do it, that's always nice. But anyway, thanks again for watching, and hopefully I'll see you again when I've finally got my own toroidal props printed and flying. Seriously, I got my hardened steel nozzles arrived, and the filament's drying in the printer, so this will be printing very, very soon.